Good day, students. This is the recording of lecture 6, which we were supposed to have on 10th of May. It's analyzing research data. The objectives of this lecture first will be to revise data collection instruments, which we covered much earlier in the semester. Then we'll be expecting to have some basic understanding of quantitative data analysis, basic understanding and skill on how to use RapidMiner for two purposes: to prepare data and to present the data. We also will understand how to interpret data analysis. For further reading, for the purpose of the exercise we'll carry out, I will be giving you a data set which we collected sometime back in 2020. At that time, it was the onset of online learning, and we initiated this study within the Faculty of Engineering, Built Environment, and IT to check how prepared our students were to go online. So it's quite a rich data set. We'll play around with it to learn a few things about research data. Maybe before I proceed, let me explain that in most projects, even the ones your students have chosen to carry out for this module, you will collect some data. Maybe you've developed a system and you would like to know what the users feel about the system. So you may administer a questionnaire. Once you have that data, how do you analyze it? How do you make an assessment of what the users are saying in that data? So that's what data analysis is all about. In some cases, we even need to collect data before we develop the system to be 100% sure we're developing system for the people we think we are, or we plan to, and it will serve their purpose. So for a revision, I didn't say that there are different ways of collecting data. For example, you can use a questionnaire, you can do interviews, or you can form focus groups. In some cases, you can even observe or do some simulation using experiments. But here we are referring to data that's mostly collected from people, from respondents. So, and we did discuss the advantages and disadvantages of each of these, and when are you supposed to use them? For instance, if you're collecting data from thousands of people, it makes sense to do a questionnaire. And but one of the disadvantages that is the data there doesn't tell us the whole story. It's just quantitative, doesn't have qualitative aspects. So if you want to collect data about qualitative aspects, then you can do interviews. And for both questionnaire and interviews, nowadays, you don't necessarily have to go visit people in person. You can use online tools. For example, you can create your questionnaire on SurveyMonkey or Microsoft Forms or even Google Forms. You then send the link to the respondents. Interviews too, you can set up virtual meetings on Zoom, on Teams, and then speak to the people, or you can even phone them. One of the things with interviews, because it's intimate, in other words, you need to speak to people sometimes for a long time. It's important to adhere to some principles. For instance, set up meetings, ensure you're there on time, ask for permission if you want to record them, explain everything. And then the last one is focus groups. Usually this is, for example, a set of users you want to work with throughout the project. So you form a focus group of specialized people. So again, just remember that you choose tools that are appropriate for the data you want to collect. Don't collect data before you follow all the ethical clearance procedures required for your specific project. And in some cases, you might need to pilot In other ones, so you have a 3-page questionnaire, you're not sure how users will perceive it, or even if they understand it. So you can always do a pilot with a lesser number, let's say 15 people, and then listen to the complaints or difficulties they have, use those to enhance or to fix, to ensure you have a final workable instrument. Also, especially when you're doing live projects that involves real life systems, and you've sent people to collect data on your behalf, it's always good to find a way of going back to a few of those and validate that the data was correct. In some cases, when you send people, because maybe you're paying them based on number of questionnaires they administer, they might want to fabricate or cheat. So it's before you use data to make conclusions or to make a decision about your project, find a way of verifying what they're saying. Or if there's some respondents, for example, if you give students have a long questionnaire to fill for you because they feel it's too much work for them, sometimes they just take things without checking. So it's important to verify. So there are different ways of checking this to eliminate such problems. Please ensure that before you proceed with this lecture, you have installed RapidMiner as explained via the WhatsApp group, and follow the links, the two other links I've provided here. This is just a minor issue here with the spelling, sorry about that. This is RapidMiner. And then the videos is about the basic introduction to RapidMiner. I'm also going to give you a PDF file, which is of chapter 7 of the book that I recommended for this module. You don't have to read it page to page. You can always check the areas that you have problems with and then read those. In my slides, I've also included some extracts from another book, but for this one, you don't need to acquire the book. It's just for reference to indicate where the slides came from. So there are two, like you remember now, there are two types of data you can collect. When you use questionnaires, you end up with quantitative data, numbers, figures. While you use interviews, they are not numbers most of the time, they're stories. People explain to you at length what they do, what they intend to do, what they like. So these are not numbers. Analyzing qualitative data is more difficult. We will not be discussing it in this course, but it's important that you know if you use interviews, you need to use qualitative data analysis approaches to analyze that data. And here are some of the things you can use. In fact, for qualitative data analysis, there are less softwares to use. For one of the most recent one is Atlas TI, and there are two others here. So just a note, this exists, but we'll not be going to details about it. We will, however, spend time looking at quantitative data, the numbers. How do you analyze that data? For instance, simple and small quantitative data set can be analyzed quite easily. So if you interviewed 21 of your classmates, it's easier to scan through and say, oh, most of them are saying they don't like online assessments, while only 3 of them say they like it. So it's easier by just a glance. Or you can just pick your calculator and end up how many of them saying they like it 40%, others 50%. You can end up and do an average quick. When the data set is big, like the one I'm going to give you, however, which is over 3,000 respondents, then you need to employ tools that can help you analyze that data. Numbers can easily be counted, and summaries of counted numbers can be meaningful. So immediately we are using simple data like the example I gave. You want to know if a new system that you can use to invigilate students sitting online exams won't be useful. And you have asked 20 students about it. You can easily see 70% are saying, oh, no, that will be useful. 30% say it's not. And that can give you confidence to go to the next level. Summarizing statistics are examples of descriptive statistics. So today we'll be talking about two types of statistics. It's the descriptive one that you use to describe data, majority of, minority of, frequencies of, the mode, the mean. Those are all descriptive statistics. So the numbers are presented in the next slides. Now I'll show you. But before that, the one of the most powerful software used for quantitative data analysis is SPSS, which is the statistical package for social sciences. In the past years, even last year, some of you were in fourth year under chance to go through this. We've been training the students to use SPSS. We currently do not have 2022 license for this, so we'll not be using it this semester. However, I'll introduce you, like I said, to RapidMiner. Although RapidMiner is not a data analysis tool, but it supports some basic data analysis. And the good thing with RapidMiner, especially for us in IT, is that later you realize you can go ahead and use it for data mining, machine learning, predicting models, which are very relevant to IT students. So to me, it's actually an advantage of using RapidMiner for IT students at this stage, because it opens up doors for many other computer-related analysis, especially machine learning. Here, just a slide that explains the different states of data analysis. The first one, you need to describe your data. It's not advisable to jump in and start analyzing the data. You need to create a format, a sequence. Ask yourself, what will I be looking for? How should I look for it? What part of my questionnaire will I use to answer specific questions in my data analysis? In the first phase here, data analysis, the researcher engages in descriptive analysis. Describe it. You describe the data, what it is, what you see in the data, and so on. Once you have that, so the example is saying, oh, I see that 60% of respondents like the system. You need to then go to the next level. Interpret it. What does that mean in the context of your project? So here you move from describing what you see in the data to interpreting it. That is explaining what does the data mean for you. In the data set I'm going to show you was CUT, we were looking at, for example, three main things. Do the students own a computer? Do they own a smartphone? Interesting also, I was trying to find out what kind of internet connection do they use? Do they basically use their phone as hotspot? Do they have Wi-Fi at home? Do they have broadband? And the fourth one, which we found interesting, was, do they have a quiet place where they can do their reading from? Because even if you have all those things and you're living in a house which is congested, you may never have time to do your online learning. But once we have that information, then what? For example, you can interpret and say that it looks like all the students, or most of the majority, 80% of them, are using smartphones for their learning. Therefore, the kind of training material we need to prepare to give the student should be accessible through a mobile phone. Specifically in the Department of IT, this became very critical because if students are programming from their phones, you don't expect them they are going to install Android Studio. It will never run on a phone. So then you need to go beyond just counting 70%, go to the point where then what? What does that imply? That's what this means. And then of course you need this where you do the conclusion with all the 10 parameters you're looking at. What is the conclusion? What is the major conclusion? And what is a minor conclusion? And the last one, although we will not do it for fifth year project, is the theories you can deduct from it. This applies mostly to master's and PhD research, where there's some theories that is going to be discovered. So for now, it's just for you to know it exists, but we will not be going into it. So in a pictorial format, we start with description, we interpret, we conclude, and then we generate a theory. But like I said, for a project, we'll not be generating theories. So basic statistics here means the descriptive part, where you summarize the mean, the median, the mode, and so on. And the most commonly used are frequencies, ranges, means, modes, median, and standard deviations. You can always check the meaning of this. I'm sure some of you have already seen that you can actually extract the same using Excel. When you go to, just to flip back, when you're interpreting after describing, here we say you're doing inference analysis, where you use the data gathered from a sample population to draw conclusions about the population. So I was saying that as much as we received responses from 3,000 students, CUT has over 22,000 students. So from the 3,000 whose data we have, what is that we can conclude from that data set? And how does that then inform the university decision-making process? When you're doing that, we're saying we're doing inference statistics. So can read a little bit more on this. Again, using RapidMiner, it's possible, especially if you go to predictive, because RapidMiner supports prediction. Use the data you have to predict what would happen in the future, or what would happen if the set was larger than, like in our case, the 3,000. When you're doing data analysis, you can decide to use only one attribute. I will show you in a moment in our data set. E.g., you want to say, for example, you want to look at frequencies. What is the frequency of people who have laptops vis-a-vis the ones who don't? So in that case, you're only using one variable for your data set, which says laptop ownership or computer ownership. We can decide to say, I'm going to look at this data using two variables. In this case, you want to know based on where the student lives. Do they live in a township? Do they live in a metro? Do they live in the rural areas? Do they live in a small town? So the first value is where they live. The second one is if they have a quiet place to study. To just correlate, is there a relationship between people who live in bigger cities and availability of somewhere to study, as opposed to maybe if you live in the rural areas, there is less noise or something like that. So in that case, when you use two variables, then you say you're doing bivariate analysis. The moment you're using more than two, then it's become multivariate. So we'll be doing the three types using the data set we have. One other thing about data analysis is that use of graphs is better than numbers. The moment you see a pie chart that shows yes is 10% and no is 90%, it gives a bigger picture, an immediate reaction from you. Or if it's a bar chart that's showing there's a spike on the number of people who own computers when you're looking at Department of IT, vis-a-vis if you're looking at the Department of Education. Those kind of graphs are part and parcel of data analysis, because like say a picture speaks 1,000 words. So you can draw graphs, whatever software tool you use, you can draw graphs in them. You can even draw them using Microsoft Excel and then export your graphs to your report, Microsoft Word report. So at this point, I'll play for you a video of RapidMiner. It's my assumption that at this stage, you have already installed your RapidMiner, and this will be like a revision for us. Just give me a second. I'm going to share different screen.